Well, thank you all for coming to this wonderful session with about 25 other competing sessions. So I really appreciate you showing up and coming. This is the intro from source to image. It was written up as source to image, and I'm obviously with OpenShift, and I have a bias towards our tool, source to image. But we all know that there's many, many tools out there and tool chains for building images, and what we'd really like today is to go into some of the key concepts around that today, and tomorrow we have a deeper dive at 3:40, and we are not really going to be source to image centric like that tool. What we're really going to try and do is have a conversation about what it means to be going from source code to image, and we'd really love to hear feedback from you on where we should be going next, where there could possibly be any convergence on all the different toolings and approaches, so that we could maybe not have so many, or just have one bunch of wonderful ones. So today we have Ben Parees and Matt Moore from Google, and they're going to walk you through an introduction to the key concepts, and then I'm going to get out of the way.
Hi, welcome. So yeah, I'm Ben Parees. I lead the developer experience team for OpenShift, and that one of the main core missions for us is enabling developers to take their application source code and turn it into an image on the OpenShift platform and then get that image running. So one of the tools we maintain is what I'll refer to as S2I, which is specifically the command line tool for doing source to image, as opposed to the general concept of going from source to image, which is what we're going to talk about today.
I'm Matt Moore. I'm with Google, and I wear a lot of hats in the container space. For the purposes of this talk, let's say I'm the ubertl for container development stuff.
All right, so first off, we're just going to lay out the framework of, so what do we mean? We've now confused you about S2I versus source to image, so we'll try and explain that, get through why you should care about that. You probably already have some ideas since you came to this session. And then we're going to go through some of the different approaches that are starting to evolve in the ecosystem around how you do this. And then that should be a relatively short part of the session because we want to open the floor to discussion. As Diane said, we want to hear what people in the community are doing, what challenges do you have, what are some of your thoughts on this. If you don't have those questions, we have backup slides. So, you know, that's the threat. So what do we mean when we talk about source to image? In general, we're talking about just a way to go from I've got my source code in a repository somewhere and I need to turn it into a runnable application image, probably because I want to run it on Kubernetes. So I've got a bunch of source code. How do I make that into an artifact that I can run on my cluster? And then more ideally, we want to do that by hiding the details that are going on when you're constructing the image. So when you write a Docker file, you're exposed to some pretty ugly details of what it means to construct an image. And application developers shouldn't have to care about those things. And it's actually dangerous in some cases to let them do it. They might produce less secure images. They might produce less efficient images. They're not going to follow best practices. So by limiting the things they have to worry about, you can guide them down those best practices. And then you're also just keeping them from having to learn about things that they don't need to know about. They know their source code, they know how to build source code. They don't necessarily know Docker files. They're certainly not experts in the right way to construct Docker files. Anything you want to learn there? All right, so why do you want to go from source to image? Well, Kubernetes runs images, so you need to figure out how to get your application source code into an image. You therefore need to be able to build images, and this is kind of leading to what we're going to talk about more tomorrow in the deep dive, but if you're going to have to build images, why not do it on the cluster you already have to run anyway? Don't have a separate set of infrastructure. Certainly you don't want developers just building their images locally and shipping them into production. So you've got a cluster, let's build our images on this scalable cluster of resources that we already have. And important note, we have to do that securely because we don't want to produce an exploit in our cluster when we start building images on the cluster. So just an advertisement for our deep dive session tomorrow. Today will be less cluster focused and more specific tool focused. All right, so going through some of the approaches. So we're starting with the basic one that I would imagine everyone in this room has used. You are just going to use traditional Docker build. You've got a Docker daemon available. You invoke Docker build from a directory that's got your source code and a Docker file. The Docker file knows how to assemble your source code. And then you Docker push that image to somewhere that you're ultimately going to deploy onto your cluster. What's good about it? Everybody who's doing stuff on Kubernetes probably knows how to do this today. So kind of a low barrier to entry. The downside is to do it, you need to hand out Docker sockets. And so either that means the developer doing it on their own machine where they have a Docker socket, or you start handing out access to the Docker socket on a shared cluster, which is a really bad idea. There's lots of ways that people can essentially root your host system if you've given them access to the Docker socket.
Or Docker. Or Docker and Docker, which is just as bad.
All right, so with that table stakes out of the way, we move on to some of the more sophisticated techniques, which we'll refer to as daemonless Dockerfile builds. So your input artifact, still a Docker file, but you're not using the Docker daemon to build that image. You're going to use a different tool that will not require a Docker daemon. So most of these techniques involve running a container themselves and then essentially executing your Docker file commands within that container and then committing that container as a new image. There are some other tools. Matt, if you want to talk a little about what they do.
You want to talk about that on the next slide?
Oh, sure. We didn't get a lot of time to practice this together. So, yeah, but the other alternative is just constructing the image layers directly, which we'll get into. So what's good about this? Well, it's similar to your Docker build experience. So if you're used to writing Docker files, you're still writing Docker files, still works. It gives you a little bit more control over what image layers are produced, or at least the tool itself has more control. That tool may expose that control to you. So that means that instead of a Docker file that might produce an image with 20 layers, you might be able to produce an image that only has 2 or 3 thicker layers, and that might be better for caching reuse and pushing and pulling those images.
Or a lot of layers, right? Which can lead to better performance and potentially better cache hit rates, right?
Yeah, right. It could go both ways on that, but gives you a little bit more control over that. And it also, again, the aim here is greater security because you're not requiring the Docker daemon, so you're able to let people do these Docker builds in a more secure way. The downsides to these approaches in general, and again, we'll get into more specific tools, but Docker file fidelity is the biggest one. So Docker build is going to do one thing with that Docker file. These other tools are going to do their best to keep up with the Docker file spec and perform the actions that would be expected in that case, both because of the Docker file spec moving from time to time, as well as because of the technologies that these tools use. It may not match exactly the behavior that a Docker build would produce for that Docker file.
That said, I think the state of things today is significantly better than a number of years ago trying to do this, since I think a lot of the sort of handling in the daemon for how those are parsed and whatnot has actually been factored into a more reasonable library than it once was. So you can actually leverage a lot of the same facilities for parsing that and interpreting the file than you used to be able to do, which was pretty much roll your own.
And then the other thing to consider with this is the also perk of the different approaches to image layer construction. That may be a negative, or some of the tools that don't give you control. They might give you only one fat layer, and you don't want only one fat layer because you're not getting cache reuse when you rebuild the thing. Or it's resulting in having to push that layer, the whole fat layer, every time because one byte changed in it and you're not getting any layer reuse. So that's both a pro and a con potentially. We'll start with Builda. All right. So there's a couple of tools that we wanted to go through that implement this daemonless approach. So Builda is one that's based on the runc container runtime, and so it rather than using the Docker daemon to spawn a container, is able to actually launch a container itself directly. And then, as I mentioned earlier, it runs through the Dockerfile commands within that container that it launched to add your source code, run your run commands, and then, again, when it's done executing all of those commands, it commits the new image as a single new layer. So doesn't require a Docker daemon, but gives you Dockerfile execution of those commands.
So IMG is one, neither of us was involved in, but it was, came out recently. From the README, it's, I think, fairly similar to Builda in terms of how it operates. The quote from the README is, you could probably even use Builda as unprivileged if you use the same instructions for unprivileged mounting. So I think as part of what Builda is doing with runZ is it's mounting in different things and doing file system snapshotting, which I think require certain capabilities, even though you're not using a daemon to achieve those things. Conoco is a relatively, well, an even more recent Dockerfile-centric build, which it's, I would say, optimized for being run, invoked by a container orchestration system, which sort of speaks to the talk tomorrow. But it expects to sort of be executed in an empty container, and then it does an evaluation of the Dockerfile constructs and does its own snapshotting without, speaking to, file system driver, and publishes the image directly to the registry. So it's effectively making zero privileged syscalls aside from what you may have in your run commands, but it expects to have been bootstrapped by a container orchestration system in advance. One of the things worth calling out here is when this came out, gvisor wasn't announced yet, but they are very complementary. So if you haven't seen that or read through that yet, I would highly recommend it. It's pretty cool.
Okay, so that wraps up the tools we were going to cover, at least for Dockerfile-based builds. So the second approach is what we call Dockerfile-less builds. So in this case, from a developer perspective, there is no Dockerfile to worry about. This is getting to the real, I'm just a developer who only cares about source, but I've got to produce this image because my boss told me that we're deploying everything on Kubernetes, and I don't know what that is either, but I'm going to write my source code, and I need to somehow get that source code onto a cluster. So the user's just specifying their intent and their source code. I've got a bunch of Java code, and I want to run it on a Wildfly server. I've got some Node.js code, I want a Node.js server. Some of the tools can also even incorporate detection into it. I believe Scaffold is one that will do some of that as well. Just detecting what sort of language you're using and matching it to the right image to apply that source code to. So the advantages to these Dockerfile-less approaches are less configuration for the developer. Again, they're really only concerned with their source code and maybe what framework they need to be using to build that source code. And the tools can actually do some of that decision making about what should be a layer in the final image. So the tool can say, I'm going to produce a layer that's the application framework, and then maybe another layer for the dependencies for the application, because I'm not expecting those to change too often, and then the top layer will be the application code that changes most frequently, and so you get really good reuse as you're iterating on building that application.
One thing I'll just add, right, like from my perspective, right, like this is the goal, right? Containers have been really hyped over the last few years, right? But ultimately, I see them as sort of an infrastructural implementation detail, and you shouldn't have to worry about, understanding how to hold every single aspect of it right in order to use them really well. Ideally, right, like you should just be able to containerize your application and then run your application and not need to worry about all of the mechanics of how everything gets stitched together, so.
So another advantage to this is because the developer isn't responsible for writing the Docker file and they're not responsible for the base image that their application is going to end up running on, That means that the organization can produce a base image for your Java workloads or your Node.js workloads that codifies the best practices for that image. So again, what libraries you want in it, what ports should the image expose, what layers should it have, how many layers should it have. All of that is, again, just baked into the image or handled by the tool, so you don't have to worry about the developer having to understand those nuances or getting them wrong.
So one other thing that some platform providers are taking advantage of with this approach is if you control the process of how things are containerized, you can also constrain the ways it's constructed so that doing things like rebasing, which scares me a lot in the presence of arbitrary Docker files, it is actually a more approachable problem, right? You can actually decouple and service the base runtime independent of rebuilding the whole thing, because the build itself may actually be expensive. And you may just want to be able to swap in a new version of your base runtime image, whatever that is, to pick up a glibc update or something, right?
So the downsides to this are it is going to be significantly less flexible, again, depending on the tool that you're picking to implement this approach. But just as an example, the S2I command line tool is by design less flexible because we were trying to some extent, take power away from developers, power that we didn't want them to have to shoot themselves in the foot. So at least with default configurations, when you do S2I builds on OpenShift, you can't perform any root operations as part of your build. So you're restricted to standard user operations within that container, just as one example. And then the other challenge, as you'll see on the next slide, is there is no standard here. There are a lot of different ways to go at this. They're all kind of trying to solve the same problem, but in very different ways. And so it still means the developer may have to learn one of these tools and understand the nuances of it, or the organization has to pick one to adopt. So the ones that we were going to cover today in brief are S2I, which has been around for a number of years at this point. It was sort of the first thing that we at Red Hat came up with to try and approach the problem of how to enable developers to do secure builds on a multi-tenant platform that we saw that we were going to be building on top of Kubernetes. So with Source2Image, it's sort of what I described earlier. The user provides their source code. That source code gets built and layered into an application image based on top of what we refer to as a builder image. So it's dependent on this ecosystem of builder images, and we supply a number of them, but the hope is for other people to contribute their own, or within an enterprise, they may just build their own internally, which we see sometimes based on their own language, or because they have a specific version of a framework that they want, or they want to bake specific dependencies in. But you provide those builder images, and then the builder image understands how to consume the source code and produce the application image.
So another example in this space is actually build packs, which were invented by Heroku and adopted by Cloud Foundry and Deis. And some work has been done to bring these into the world of producing container images, where you do a build to produce an application slug, and then these are then bound to a base image in order to actually create a runnable container image. And these are one of the contexts in which having that contract for rebasing is actually kind of nice, and it's enabled by the fact that they have control over how it's built and ultimately composed. FTL is sort of a technique that's used for a number of purpose-built source-to-image builders that are used. Oh yeah, FTL stands for faster than light, which was sort of a tongue-in-cheek name for the technique. Ultimately, it's the insight is taking sort of looking at sort of application dependencies in the same way build systems do, and projecting sort of the incrementality that gives build systems into the layering of the application image, so that you get very incremental pushes and pulls of images, ultimately to give you faster cycle times. one of the instances of FTL is Jib, with some of the folks involved in that are here in the audience. And let's see, the fourth is Bazel, which actually has a lot of configuration. But a lot of the ideas that went into FTL, which is not Bazel-based, stem from work done in Bazel long ago to give Google the capacity to produce Docker images from our internal infrastructure, where sort of the fundamental constraint was Googlers don't have privilege on our internal distributed build, so how are we going to produce Docker images since we can't run a daemon? So that was sort of the origin of some of that work, and that inspired a lot of the sort of direct image assembly stuff that went into stuff like FTL. Okay, so a number of observations from sort of looking over the landscape is that, there's a clear trend towards trying to make the image build process more secure. This is, going on both in the context of these source-to-image builders, as well as, it's become a hot topic in the last couple months, certainly around producing Docker images from Docker files as well. And this is often in support of trying to enable on-cluster builds, which again is what we're going to talk about tomorrow. There's a clear interest in trying to produce better layered images, either fewer layers or many more layers, depending on what it is you're trying to do. It's really easy to actually end up with redundant stuff in layers and whatnot. Trying to get better control of that is definitely one of the things that's often discussed. There seems to be a lot of interest, but sort of a clear gap in standardizing a way to do this sort of process of taking the source and producing the image. So yeah, anything to add?
No, I think you covered it. This is sort of what we see the state of the landscape as being, and where we see it headed as well. So now we'd like to open the floor, hear a little bit about some of your experiences with how you're building your images today, whether you have experience with some of these tools, or maybe there's some other tools that we didn't cover.
Right, this wasn't meant to be exhaustive, just to be sort of a sampling of things that either we're involved with or know folks involved with or heard about.
All right.
We'll repeat the question if...
Yeah. So is there anyone, there's a Jib person in the room. Are there any other people who are building tools along this state? I think I saw a few people in the back who had come in that were...
There's a bunch of them.
There's people hiding in the audience.
There's a bunch of them. We'll just shine a spotlight on them if someone asks the right question.
I also did want to mention, the slides are online, but we have links to all the tools we talked about. So if you download the slides later, you can go to all the various cool repositories for those.
I am always a fan of abstracting complexity away, but when I'm implementing DevOps, there are every time people who want to have more power and more privileges, and we always end up in this topic using abstracting every feature of the Dockerfile again into another form. So, or we would have to cover two pipelines, one abstracted and one native Docker pipeline. What is a good way to to bring such a philosophy into a company?
Well, I think, you have to consider the context of, are the requirements valid, or are they just, I just want to be able to do this because I can do it, and if the processes say, well, you don't have to do it, we're not going to let you do it, then you can enforce that. But I think that's also where some of the the Daemonless Dockerfile approaches are probably going to be useful for those scenarios where you're still able to empower people to do their Dockerfile build without the risks of a Docker daemon-based build.
No, I think that's, I think there's a use for both, and I think that we need a better solution for both. I think that ultimately, I think I see it sort of partitioning a little bit. I think that ultimately having the capacity to containerize applications is really useful, but a lot of the times those applications have sort of system dependencies that may not be in a base image. Like I want to shell out to Git or something, so I need, you know, a package manager to install something, right? And so I think you could, I think an interesting knob I've seen in terms of sort of source to image stuff is, okay, well, curate a base image using a Dockerfile approach, but you can still then potentially consume that base image with sort of source to image style techniques. And so I think in practice having that knob has felt like an interesting, you know, way of toggling between those and blending those worlds, but rather than exposing those knobs at the source to image layer, if that makes sense.
Yeah, just to follow up on that, because Matt sort of reminded me, I mean, we see this a lot with S2I, which is we produce this curated set of S2I builder images, but they don't necessarily include every library that you might want to use with that framework. And you can't necessarily add those libraries with the assemble script if they have to go into the system directory or something like that. And yeah, our message around that is, great, it's a Docker image, write a Docker file that extends it and adds whatever else you want one time, and then tell your organization, here is our S2I builder image for this framework that includes our internal libraries or these other dependencies. We even have S2I builder images for databases where the source you're injecting is your configuration. But again, if you need to add additional drivers or plugins, then maybe you extend that image with a Docker file. But you don't let everybody do those Dockerfile builds. You know, there's a group that is curating your ecosystem of images for the organization, and then there's the people who are consuming those and just layering on their source code.
I think there's also a number of sort of enterprise scenarios where some of those restrictions are, you know, are things where like you don't want people doing certain things, right? And you should tell them no, right? You know, reaching out and installing arbitrary packages, you know.
Curl pipe to shell.
Yeah. So the non-hermeticity of it and whatnot, right? Like if you can reach out to the internet, pull down whatever you want, right? Like that can be a nightmare for a wide variety of sort of enterprisey scenarios around provenance, reproducibility, et cetera, et cetera, et cetera. So. You know, just say it and we'll repeat it.
Thank you. I was wondering if this framework does have an idea of linting Docker files or linting the best practice that we are using in company. That means what should be like, it's not like OpenSCAP that you're using like OVAL or something. It's the idea to have a linting of how it should looks like. I mean, there are in Source2Image you have Source2Image, but we have custom builders and we have other stuff. But I'm interested if we can force it to somehow lint it. How should be a Docker file look like?
So I'm sorry, was that to force S2I to do this, or just a tool in general that's going to like lint your Docker files essentially?
Sorry, it's linting in general, but the question is, if you give the end user the freedom to adapt something on your Docker file, it should be in the same shape all the time, and then you have to control it. And within code we do that, but can we do this also within a Docker file?
So one thing I'll call out is, you know, I won't speak to S2I, but for sort of the source to image techniques in general, one of the things that is appealing about not going through a Docker file for, or even at times a Docker daemon to do that image assembly, is that you aren't constrained to what layering can be expressed through a Docker file. So each directive in a Docker file gives you a layer. So if you look at what FTL style builders like Jib or the ones we have for Python and Node are doing, we're basically producing a dynamic set of layers based on the transitive dependencies of an app. And you can't, short of reading that and spitting out a Docker file, it would be very challenging for you to write sort of a static Docker file that could produce that layering. And one of the things that I think I'd like to see from some of the daemonless Docker file builders is, in addition to supporting things like squashing layers, which can eliminate redundant downloads for copied or overwritten files, is starting to embrace techniques around partitioning that mega layer into a set of things that can be uploaded and downloaded in parallel and potentially give you, like, if var foo doesn't change, right, then the layer with that won't need to be re-uploaded, won't need to be re-downloaded. And so you can partition the change in your application and get much faster cycle times.
It's the last question. I'm wondering how we can we approach the multi-stage environment? That means we're normally creating somewhere something. There is JDK, and in the production area we just run GRE. And how is the way this tooling help me to have multi-stage stuff? I mean, today I can do in Dockerfile, I can do a builder stage and a add stage from the output. Can this stuff here also be done?
So when you're talking about stages, you're talking about sort of promoting the image through from you've done development and then multi-stage Docker builds themselves. So I believe that at least Builda, for example, will actually support that. Do you know offhand if Conoco?
Conoco should support it, right, in the future. Doesn't now, but I'm eyeballing the product manager.
And then for the tools like S2I, I would almost say S2I is already inherently a multi-stage build. Your first stage being you produce the builder image, and your second stage is you add the application code to that builder image. Yeah, so S2I itself, we actually experimented with a feature called extended builds in S2I where you could supply a separate runtime image, and what it would do is do a first build that invoked your assemble script, produced artifacts, produced an image with those artifacts, then extracted those artifacts and added them to your runtime image. We briefly introduced that in OpenShift and then decided that actually that was too inflexible, and so we instead promoted what we call chained builds in OpenShift, where you actually just do multiple builds, but we allow you to pull artifacts from one image and use them in another build. And so it was just a more flexible way rather than being completely tied to S2I.
So to echo that, right, we have a slightly different approach in Google Container Builder where you basically have multiple steps in a build where there's a shared workspace you can use to copy things between things, but both predate multi-stage Docker files. To your point though, right, I think this touches on the, these source-to-image builders sort of enforcing best practices. I think one of the best practices is JDKs are for building and JREs are for running, right? The most extreme example of this is from Golang, add my source, go build, and then set the entry point to the binary, right? Like that is a huge image that's invoking, a statically linked, couple meg executable. And so you're downloading huge amounts of data that's just pointless, right? So yeah, I think that's absolutely a best practice that hopefully users don't have to, can use one of these tools instead of having to curate their own multi-stage Docker file and worry about how they copy things in between it. But yeah, then they'd have to live with the constraints. Not a question. So Kim is the product manager for Conoco and Scaffold. And she says there is a PR out to add multi-stage support to Conoco. Yeah, that was really fast. Nice job.
She did it from her phone, yeah.
To do multi-stage, no. Steve?
I was just wondering if you did an audience poll, like who like needs Dockerfile-based build, or who
Yeah,
really cares?
that's a really good question. Raise your hand if you do Dockerfile-based Docker builds. Okay. Raise your hand if you do some sort of source-to-image based Docker flow. All right.
And raise your hand if you don't think you need Dockerfile builds based on what you learned today. Cool.
All right. Are there any other questions? There's one here. Try.
Different one. Just a small question. Have you used HashiCorp Packer? I kind of looked forward to seeing something about it because it has like 8,000 stars on GitHub.
No, I haven't used it directly. My understanding is it's similar to Dockerfile builds in so much as you effectively enter some base container, execute the set of commands, and then it snapshots it. So while the Dockerfile daemon driving, whatever you want to call it, isn't being done by Docker via Docker build, it's still how the Packer process is driving that Docker build, is my understanding. Don't quote me on that because I don't think I've looked at it in years, but that's my understanding of how that's working.
I did some experiments with Packer, but it made only one layer.
Oh, yeah.
Basically, it created only one layer, so it didn't really work out because I had a very big layer. But because it was nice, I thought that Packer you can use, for example, I had some Ansible role, so I thought it was nice, I can reuse that to create my image. But yeah, I went back to Dockerfile, basically.
Yeah. If that's how you're driving it and you're only doing the single snapshot, which is what I think Packer's doing, you end up with a single layer.